Welcome back. In this lesson, we will learn about multiplication and division of complex numbers. Multiplication and division of complex numbers we did under the first or second lesson, but I said that multiplication and division is somewhat complex or somewhat difficult in that one. So here we will find an easy way of doing it. If you take a complex number, say Z1 is equal to R theta 1, R1 theta 1, and say complex number 2 is Z2 is equal to R2 theta 2. Now both these are in polar form, what we learnt in the previous lesson. So these numbers are given in polar form. In polar form, the multiplication of these two numbers Z1 and Z2 is quite easy. We have to multiply R1 by R2, and of course the resulting angle will be simply the addition of the two angles or two arguments. So in polar form, the multiplication becomes addition of these two. Of course, the two modulus we have to multiply, but the argument will be added. And if you want to reconvert this back to the rectangular form, you can do so. So we will go into these examples later on. And so this is multiplication, and next let's do how the division of two complex numbers, of the same complex numbers. So if we want to divide Z1 by Z2, it is simply R1 over R2, and the angle will be the difference. That means theta 1 minus theta 2. So in polar form, multiplication of two complex numbers, we multiply the two modulus, and then the angle will be simply added. And in division, we divide the modulus, and then the argument will be simply the difference. So let's do one example, and then we can easily understand. So example 1. We take Z1 as equal to say 3 plus J4, and Z2 is equal to 12 plus J5. So if you want to find Z1 times Z2 and Z1 over Z2, what these values are, then first let's convert these Z1 and Z2 to their polar forms. So Z1 is equal to 3 plus J4, and we can find the argument, we can find the modulus. So Z1 modulus is 3 squared plus 4 squared square root, which is 9 plus 16 square root, which is 25 square root, and that is equal to 5. And argument z, arg z is equal to 4 over 3, which is 1.33. Sorry, this is tan inverse, so it would be tan inverse 1.333, which is equal to 53.13. So our first complex number z1 can be represented in polar form as 5 angle 53 13.13. And let's take the second complex number. Z2 is equal to 12 plus J5, and here the modulus is equal to square root of 12 squared plus 5 squared, which is equal to 144 plus 25 square root, that is 169 square root, which is equal to 13. And argument z2 is equal to tan inverse 5 over 12, which is, the angle is 22.61 degrees. So z2 can be represented in polar form as 13 angle 22.61. Now, if you have to multiply, say, z1 times z2, that is simply 5 angle 53 13 times 13 angle 22.61 degrees. And now we just simply have to multiply 5 times 13, and we have to add these two angles, 53 13 plus 22 61. So 5 times 13 is 65, and when you add these two, we will get 0.74 22, that is 5 and 75. So that's the answer. Now, if you want to reconvert this to the rectangular format, then that also we can do, right? Z1 times Z2, shall we say that is equal to Z3, which is equal to 65, 75 degrees and 0.74, and we can say Z3 is equal to 65 cos 75.74 plus J sin 75.74, and of course we can find the values there. So 65 cos 75.74, so that is 75.74, cos is 0.2463 plus J sin 75.74, that is 0.9691, 0.9691, and when you multiply by that, we got here 16 plus j into 65, so that is 62.99, say 63. So that's the final answer. So that's multiplication of two complex numbers. Now let's do one more example. Example number 2. We'll do a division. We can do the same two numbers. That's Z1 is equal to 3 plus J4. Z2 is equal to 12 plus J5. So we will divide Z2 by Z1 instead of Z1 by Z2. So that is 12 plus J5 over 3 plus J4. Now this is very difficult to do. So what we do is we use the polar format. So Z2 we found it is 13 and angle 2261, and that is divided by 3 plus J4 is 5 angle 5313. So now it's a matter of dividing 13 by 5, and 13 upon 5 is equal to 2.6, and this is 22.61 minus 53.13. So that is actually 53.13 minus 22.61. So that is 2.6 negative 30.52, and that's the answer. Like earlier, if you want, we can convert it back to rectangular form. So that is 2.6 cos negative 30.52 plus j sine negative 30.52. So that gives us 2.6 negative cos is 0.8614 plus j, let's say negative 30.52 negative sine, that is negative 0.5 0.507. So when you multiply by 2.6, say 0.8614 multiplied by 2.6 gives us 2.23 plus j 2.6 multiplied by almost half, so that is 1.3. So that's the answer. So you can see multiplication and division in polar form makes complex numbers very simple, or division and multiplication of complex numbers is quite simple using polar form. Next lesson we will do some more examples.